Betelgeuse is a massive red star, a monster found in the superb body of Orion. It has long charmed stargazers, astronomers, and cosmologists alike due to its sheer size and brightness. In the event that Betelgeuse were positioned near our Sun, it would extend out to the orbit of Jupiter, affirming its colossal size. Despite being located around 642 light-years from Earth, its gigantic size makes it one of the best, if not the best, stars visible to the naked eye. Recently, Betelgeuse's behavior has been bizarre, such as incredible lighting and darkening cycles, which many researchers believe signal that the T-star is approaching the end of its existence. The well-known physicist Brian Cox recently made a critical assertion that Betelgeuse is on the edge of a devastating blast, expected to occur within the next 2 weeks. This event, known as a supernova, will mark the end of Betelgeuse's life, but will provide a phenomenal opportunity for researchers to study one of the most surprising and influential events in the universe. As a red supergiant, Betelgeuse is classified as one of the largest and most massive types of stars. It has been on the astronomical radar for many years, but its new eccentric fluctuations in brightness have sparked theories that it is preparing for a supernova. When a star like Betelgeuse reaches the end of its life, its core implodes under its own gravity, leading to a massive explosion that releases an enormous amount of energy, radiation, and cosmic material into space. Betelgeuse's approaching blast is anticipated to be a Type II supernova, a specific type of celestial event that occurs when the core of a massive star collapses. The collapse sets off the release of radiation and particles, causing a shock wave that rips the star apart. The explosion will be so bright that it may be visible from Earth without telescopes, possibly even outshining the moon in the night sky for weeks or months. While such an event would normally be catastrophic if it happened near Earth, Betelgeuse's distance of approximately 642 light-years ensures that, although the blast will be visible and dramatic, it will not pose any danger to our planet. However, the event promises to reshape our comprehension of cosmic and supernova phenomena. A supernova is one of the most powerful events in the universe, releasing more energy in a few seconds than the Sun will release throughout its entire lifetime. Betelgeuse's blast will not only be an extraordinary cosmic display, but also a significant moment for science. Researchers are eager to observe this intriguing event from its beginnings, employing a variety of ground-based and space-based telescopes, including the Hubble Space Telescope and the James Webb Space Telescope, JWST, to capture as much data as possible. When Betelgeuse explodes, it will emit a wide range of radiation, from visible light to gamma rays. One of the most crucial aspects of the supernova will be the elusive flood of neutrinos, subatomic particles that rarely interact with matter. Neutrinos from a supernova can actually reach Earth before the light from the explosion because of their ability to pass through almost everything without being affected. Observatories like Japan's Super Kamiokande and Antarctica's Ice Cube Neutrino Observatory are preparing to detect these neutrinos, which provide an early advantage in monitoring the final moments of Betelgeuse's explosion. This event will also provide vital insights into the creation of heavy elements. When stars detonate, they produce and scatter elements like iron, gold, silver, and uranium, materials essential for life as we know it. Studying Betelgeuse's supernova will offer researchers a clearer understanding of this element formation process, which is crucial for understanding the formation of planets and the chemistry of the universe. While Betelgeuse's supernova is not expected to have a destructive impact on Earth, it may interact with our planet's atmosphere and magnetic field in captivating ways. The energy burst from the explosion, specifically the emission of cosmic rays and charged particles, could result in more intense auroras, expanding the regions where the northern and southern lights are visible. While these cosmic rays may briefly impact satellite communications and some Earth-based technologies, the disruptions are expected to be minor and short-lived. Perhaps one of the most exciting parts of Betelgeuse's blast is that it will be visible to everyone on Earth, not just professional astronomers with advanced equipment. For weeks, or even months, it is expected that Betelgeuse will be the brightest object in the night sky, potentially even visible during the daytime. This spectacle will captivate not only the scientific community, but also amateur astronomers and the general public, sparking renewed interest in space science and the universe. Scientists have long speculated about the death of Betelgeuse, but Brian Cox's most recent statement adds a sense of urgency. Observatories worldwide are preparing to monitor every phase of the supernova, and the data collected will be critical, potentially changing our understanding of stellar evolution, supernovae, and the distribution of heavy matter in the universe. Betelgeuse's supernova will allow researchers to refine their models of cosmic distances. Being relatively close to Earth, it offers a unique opportunity to measure how energy from such a blast travels through space. By observing the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars, astronomers will improve their understanding of the size and structure of the universe. The event will also offer a once-in-a-lifetime opportunity to investigate dark matter and how it might influence the structure of the cosmos. The mysterious substance known as dark matter, which makes up about 85% of the mass of the universe, does not emit or absorb light, making it difficult to detect. However, observing how matter and light behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in the universe's large-scale structure. Betelgeuse's supernova will also bring us closer to comprehending the phases of life of stars, particularly how massive stars contribute to the formation of elements essential for life. Supernovae are the key cosmic events responsible for dispersing heavy elements across the universe, elements that ultimately form new stars, planets, and even living things. By studying Betelgeuse, scientists will gain valuable insights into how these elements are created and distributed. The significance of this event for society is also profound. For centuries, humans have looked to the heavens for direction, inspiration, and meaning. The disappearance of one of the most visible stars in the Orion constellation will provoke philosophical reflection on the transient nature of the universe. In some cultures, such divine events have been interpreted as omens or signs of monumental change. Betelgeuse's blast may inspire a mix of awe, fear, and wonder as people from all walks of life witness the death of a star. This grand event is likely to rekindle curiosity about space, exploring the night sky, and attract more people who are interested in learning about the universe. Amateur astronomers are getting ready for the event right now, as almost anyone with a camera or telescope can observe and record the supernova. The democratization of science will unite people across the globe, all watching and recording the same massive phenomenon from their own points of view. Betelgeuse's explosion isn't just a spectacular cosmic event. It's a stepping stone for the future. Exploration. The data gathered from the supernova will inform how we study other stars, especially as we move further into space with missions to other planets and stars. Understanding the life cycles of stars and the properties of supernovae is crucial as humanity attempts to expand its presence in the solar system and beyond. Additionally, the blaze will rekindle interest in the search for extraterrestrial life. Supernovae are essential for spreading the components, carbon and oxygen, that are essential to life all over the universe. By studying Betelgeuse's explosion, scientists can better understand how the building blocks of life could spread to other planetary systems and possibly spark life elsewhere in the universe. The impending explosion of Betelgeuse is set to be one of the most significant recent cosmic occurrences. Its supernova will provide a wealth of scientific data, enhance our understanding of the universe, and without a doubt, captivate people around the world. Betelgeuse's death will mark the end of a giant star, but it will also symbolize the continuous cycle of creation and destruction in the universe, pointing out to us that from death, new stars, planets, and even life itself can emerge. During preparations for this historic occasion, the entire world will eagerly watch the night sky, anticipating the moment when one of the universe's most powerful forces detonates into view. For both researchers and stargazers alike, Betelgeuse's final journey will be awe-inspiring. As Betelgeuse approaches the final phase of its existence, one of the more fascinating and speculative possibilities related to its impending explosion. is its potential to shed light on some of the universe's greatest mysteries: dark matter and dark energy. These puzzling forces are believed to account for the majority of the universe's mass and energy, yet they remain poorly understood. Some speculate that supernovae, like the one expected from Betelgeuse, could hold the key to solving some of these enigmas. Supernovae release vast amounts of energy and radiation. Some researchers believe these powerful forces may interact with dark matter in ways we can observe and investigate. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs exist, their interaction with the power produced by Betelgeuse's supernova could provide clues to their nature. Such a discovery would be historic, offering the first direct evidence of dark matter, an elusive phenomenon that has puzzled scientists for years. Moreover, there is potential for Betelgeuse's blast to offer insights into the nature of dark energy, the enigmatic force that drives the accelerated expansion of the universe. Understanding its role in cosmic evolution is one of the most significant challenges in modern physics. Betelgeuse's explosion could provide indirect evidence of dark energy's influence on stellar death, as supernovae are thought to be affected by the universe's expansion. Observing how Betelgeuse's supernova travels through space could provide crucial data to help scientists comprehend the effects of dark energy on cosmic events and the large-scale structure of the universe. As Betelgeuse's supernova draws closer, the scientific community is preparing for one of the most anticipated astronomical events of the century. The explosion will provide a one-of-a-kind opportunity to observe the final stages of a massive star, offering insights that may have repercussions far beyond our current understanding of stellar life cycles. Even as researchers anticipate the dramatic supernova display, they are also refining techniques to study the aftermath of such an explosion. One area of focus is the formation of a neutron star, or potentially a black hole in the remnants of Betelgeuse. A neutron star is the hard core that remains after a huge star like Betelgeuse goes through a supernova. These compact objects, which can have a mass greater than the sun's packed into a sphere no larger than a city, are an area of intense study in astronomy. If Betelgeuse forms a neutron star, it will supply an invaluable opportunity to study the behavior of matter under extreme conditions. Neutron stars are also known to produce intense magnetic fields and are sometimes observed as pulsars, emitting regular beams of radiation. The creation of such a stellar remnant could offer critical clues about the fundamental physics of extreme gravity and the behavior of matter at incredibly high densities. If Betelgeuse collapses into a black hole instead, it will be another major breakthrough for scientists investigating these enigmatic objects. Black holes, regions in space where gravity is so strong that not even light can escape, have been the subject of fascination and theoretical research for decades. Observing a black hole's formation from a relatively nearby star like Betelgeuse will assist researchers in refining their models of black hole creation and better understanding the role they play in the cosmos. Furthermore, it could offer new ways to observe the mysterious event horizon, the boundary beyond which not even light can escape, releasing more information about the nature of black holes. Another important consideration is how Betelgeuse's explosion will contribute to our understanding of cosmic rays. These high-energy particles, produced in events like supernovae, can travel vast distances across the universe. While some cosmic rays are detected by observatories on Earth, others have been a challenge to study due to their unpredictable nature. When Betelgeuse explodes, its supernova will generate a great deal of high-energy particles. This could give researchers a chance to examine cosmic rays in real time and enhance our understanding of how cosmic rays affect the interstellar medium and might influence space travel and Earth's technological systems. The supernova will also serve as a natural laboratory for the study of neutrinos. As mentioned earlier, neutrinos are notoriously difficult to detect because they rarely interact with matter. However, they carry valuable data regarding the processes occurring deep inside stars. By measuring the energy and flux of neutrinos from Betelgeuse's explosion, scientists can gain a clearer understanding of the processes occurring during a supernova, including the precise mechanisms behind a star's collapse and the emergence of elements such as gold and uranium. This may enhance our understanding of nucleosynthesis, the process by which stars forge elements and distribute them across the universe. Beyond its scientific significance, Betelgeuse's supernova will likely also have a profound cultural impact. People around the world will be able to witness a rare and awe-inspiring celestial event, reviving public interest in space exploration and the mysteries of the universe. The event will serve as a reminder of the scale and grandeur of the cosmos, inspiring future generations of astronomers, scientists, and explorers to keep searching for answers to the fundamental questions of existence. As Betelgeuse nears the final stages of its life, its impending explosion is expected to deepen our understanding of the universe's most fundamental processes.